We are going to go over how to find the spread of data, which talks about variability. There are three ways in which you can find the spread of data: the range of the data, the interquartile range, and the standard deviation. So why is the study of variability important? There is variability in virtually everything that we do. People are different, things are different. The variability needs to be taken into account whenever you are talking about data. It also allows us to distinguish between usual and unusual values. Sometimes there are things that are usual under circumstances, and sometimes there are things that are unusual under some circumstances. And finally, reporting only a measure of center doesn't provide a complete picture of the distribution. We can talk about the mean or median, but adding spread towards our discussion will help us define our data sets even more. So the simplest numeric measure of variability is the range. The range of a data set is taking the maximum value and subtracting it with the minimum value. The range is only one value, okay? So in this data set of six different numbers on a number line, I would take the minimum value and the maximum value and find the difference between the two. So here, the range is 50. The interquartile range is the range of the middle half of the data. Sometimes it is more valuable than the range. And here's how it works. So we need to find what is called the lower quartile and the upper quartile. Essentially, we are looking for the numbers that would make up the 25th percentile of the distribution and the 75th percentile. So here's how we find it. First, we need to put our data sets in numerical order, and then we need to find the median. Since I have six numbers here, the median is going to be the average between the third and fourth values. Conveniently here, the third and fourth value is 15, so the median is 15. Now what the median does is it divides our data sets into two parts, a lower half and an upper half. Here we want to find what essentially the median of the lower half and the median of the upper half, and this gives us our interquartile range. So the median of these three numbers, 5, 9, and 15, is 9, and that is our lower quartile. Our upper quartile is the median between 15, 19, and 20, which is 19. Now that we have our upper quartile and lower quartile, we're able to take the difference between the two, and that gives us our interquartile range. Suppose that we had an odd number in our data set, as we do here: 7, 9, 10, 11, 12. We would still find the median first, which in this case is just 10 because that's the middle number. Now, we do not include the median in splitting our data set into a lower half and an upper half. The median essentially is our cutter. So, we have to look for the median of the lower half, which is just 7 and 9. So the lower quartile here would actually be 8 because it is the median of 7 and 9. It's the average of 7 and 9. The upper quartile would be the average between our upper half here, 11 and 12. So the upper quartile is 11 and a half. So it works the same way as the median. When you have an even set in the lower quartile and upper quartile, you need to find the average of the two middle numbers. So once I have those values, I'm again able to find my interquartile range, which is the difference between these two values, 3 and a half. So this is my interquartile range. Standard deviation is the third way in which we can talk about spread and variability in our data sets. So another measure of the variability in a data set uses the deviations from the mean, which is the difference between the value and the mean. We get an estimated average of the deviations squared, and we call this the variance. The variance helps us find the standard deviation. So I have an example here that I'm going to go through very quickly. So I do suggest that you look over the notes or you pause this video whenever you need to clarify or write something down. Okay? So here's how to find the standard deviation. First, we need the mean of our sample. I'm going to use our calculator that we use in class in order to demonstrate this. Okay? So I've already put the numbers for our data set in my list. Okay? So I need to find the mean of these numbers, which is 3.36. So essentially, the average price of a Big Mac in these 7 South American countries is $3.36. Okay, so now we need to find the deviations. Now we need to subtract the mean from every value in our data set. So what I'm going to do here is subtract the mean from every value in our data set, and thus I get our deviations. Now what I do with these deviations is I square the deviations before I add them up. This is to take into account any negative values that we probably have in this data set. You will usually have negative values, so you need to square them. So I'm going to square the deviations. Now that I've squared the deviations, I'm ready to add them together. So I can go back to my home page and I can find the sum of the deviations. So the sum of my deviations is 2.46, 2.4643. Now, the next step here is to divide the sample size minus 1 from the sum of the deviations. I will go into more details later on as to why we subtract 1 from the sample size, but this essentially takes into account any error that we might have. So my sample size in this case was 7, so I'm going to subtract 1 from 7, which would have been 6. Really simple, but just want to demonstrate. So 0.41 is my variance in my data set. It is my variance. It is this formula right here that I have. So I find the variance, and what this does is it helps me find my standard deviation. The square root of the variance is called standard deviation. Okay, so I need to take the square root of my value that I found at the end here, which is 0.64. 0.64. So the standard deviation of that data set is 0.41. Oops, excuse me, 0.64. So, what is standard deviation? The standard deviation is the average distance the values of a data set are away from the mean of the data set. So it's the average distance away from the mean. So essentially, what this standard deviation is saying for this data set is that the average distance that each of these values are from 3.36 is going to be 0.64. I will go into more details in class as to how better to interpret the standard deviation, but I just want to show you how to find it here. In AP statistics, the goal is to use sample data to make a generalization about a given population. There will be a variety of variables that you will see that will relate to the sample data or the population characteristics. This is again talking about statistics versus parameters. So, when talking about population characteristic, we use population parameters. Parameters are typically unknown and estimated using sample data. Another example of this is the population standard deviation, which is noted using sigma, the lowercase Greek letter. When talking about sample data, statistics are used. Statistics are values calculated from samples. One example of sample statistics is the sample standard deviation, which is noted using an S or an S sub x, which is exactly how it sounds, S or S sub x. So we learned about population mean, sample mean, and now I'm telling you about population standard deviation and sample standard deviation. The variables are very important to distinguish. Throughout the entire class, we will use these variables in order to define exactly what we're talking about.